Hello students, I'm here again with the third chapter of chemistry, metals and non-metals. In your previous classes you have studied about various elements and also tried to classify them as metals and non-metals. Now let us think and see some types of elements. Can you recognize the elements being shown right now? And can you recognize that which one of these are metals and which one of these are non-metals? Let's see if you know some of these. Think of some uses of metals and non-metals in your daily life. And what properties do you think of while categorizing elements in metals and non-metals? And how are these properties related to the uses of these metals? Let us look at some of these properties in detail. The easiest way to start grouping substances is by comparing their physical properties. So let us start studying these properties. Metals can be drawn into wires, hence metals are ductile. And gold is the most ductile metal, as 1 gram of gold can be drawn into wires up to 2 kilometers of length. Some metals can be drawn into sheets on beating with the hammer. This property is called as malleability. Gold and silver are the most malleable metals. The metals that produce a sound on striking a hard surface are said to be sonorous. Now can you see why school bells are made of metals? Metals are good conductor of heat and electricity. Let us understand this with the help of an activity. Set up 2 electric circuits as shown. In one of the electric circuit, place a ceramic and the other electric circuit, place the metal block. Initially, the circuit is open, and when you close the circuit, the observation is in front of you. The circuit with the ceramic does not glow, and the circuit with the metal block, we can see there the bulb starts glowing. This shows that metals conduct electricity. Now this is the reason why metal wires are covered with polyvinyl chloride. Non-metals like polyvinyl chloride helps in insulating copper wires. Metals are generally solid except mercury, which is liquid at room temperature. Metals have high density, so we can say that metals are hard and strong except sodium and potassium, which has low density. This is proved by showing that metals cannot be cut with normal knife. A special instrument is needed to cut the metals, but sodium and potassium can be cut with a knife. Metals are lustrous and are usually silver grey in color except copper and gold. On the other hand, non-metals are dull in appearance except iodine, which is lustrous. They are brittle and hence can be broken easily, except diamond, which is the hardest element. They are poor conductors of electricity except graphite, which is the best conductor of electricity. They have low melting and boiling points. They are usually found as gas or solids except bromine. Bromine is found in liquid state. Now let us talk about some chemical properties of metals. Usually they have 1 or 3 electrons in their outermost shell. So they have a tendency to donate their electrons. So we can say they are electropositive elements. Almost all metals react with oxygen to form metal oxides, and metal oxides are usually basic in nature. Out of all the metals, sodium and potassium are highly reactive with air. They vigorously react with oxygen to form sodium oxide and potassium oxide. They instantly catch fire in contact with air. This is the reason why sodium and potassium are stored in kerosene. Magnesium do not react with oxygen at room temperature, but when it is brought near the flame, it instantly catches fire and burns with a dazzling white flame. Copper, on the other hand, does not produce flame. It burns with the black deposition of copper oxide on its surface. Similarly, aluminium and zinc also do not produce flame and form the deposition of aluminum oxide and zinc oxide. These two are amphoteric in nature. Aluminium oxide can react with acids and bases to form salt and water respectively. Therefore, aluminium oxide is amphoteric in nature. Similarly, zinc oxide also can react with acid and bases to form salt and water respectively. Iron does not burn on heating, but iron fillings burn vigorously when sprinkled in the flame of the burner. Metals like silver and gold do not react with oxygen even at high temperatures. The surfaces of metals such as magnesium, aluminium, zinc, lead, etc. are covered with a thin layer of oxide. The protective oxide layer prevents the metal from further oxidation. Hence, this property of forming of oxide layer over the metal is used in the process of anodizing, which is a process of forming a thick layer of oxide over the aluminium. During anodizing, a clean aluminium particle is made the anode and is electrolyzed with dilute sulfuric acid. The oxygen gas evolved at the anode reacts with the aluminium to make a thicker protective oxide layer. This oxide layer can be dyed easily to give aluminium particles an attractive finish. Now let us see what happens when metals react with water. Metal react with water and produce a metal oxide and hydrogen gas. Metal oxide that is soluble in water dissolve in it to further form metal hydroxide. But all metals do not react with water. So the metal oxides which dissolve in water are called as alkalis. So we can say that all alkalis are bases, but all bases are not alkalis. So for example, metals like potassium and sodium react violently with cold water. In case of sodium and potassium, the reaction is so violent and exothermic that the evolved hydrogen immediately catches fire. The reaction of calcium with water is less violent. The heat evolved is not sufficient for the hydrogen to catch fire. Hence, calcium starts floating because the bubbles of hydrogen gas formed stick to the surface of the metal. Magnesium does not react with cold water. It reacts with hot water to form magnesium hydroxide and hydrogen. It also starts floating due to the bubbles of hydrogen gas sticking to its surface. Metals like aluminium, iron and zinc do not react either with cold water or hot water, but they react with steam to form the metal oxide and hydrogen. And metals such as lead, copper, silver and gold do not react with water at all. You have already learned that when acids react with metals, they give salt and hydrogen gas. Now the extent of action of acid on metals depend upon the reactivity of metals towards the acid. Now the metal which produce maximum evolution of hydrogen gas is more reactive, and there the rise in temperature is also more. So for different metals, the temperature rising is different and the amount of hydrogen gas evolved is also different. So according to that, we can arrange the metals according to the decreasing order of their reactivity. So accordingly, we can arrange the metals in the decreasing order as potassium, sodium, calcium, magnesium, aluminium, zinc, iron, etc. But copper, mercury, silver and gold do not react with acids at all. This is because these metals cannot displace hydrogen from their acids. So these elements are least reactive elements. Hydrogen gas is not evolved when a metal reacts with nitric acid. It is because nitric acid is a strong oxidizing agent. It oxidizes hydrogen produced to water and itself gets reduced to any of the nitrogen oxides. But magnesium and manganese react with very dilute nitric acid to evolve hydrogen gas. Aqua regia is a freshly prepared mixture of concentrated hydrochloric acid and concentrated nitric acid in the ratio of 3:1. It can dissolve gold even though neither of these acids can do so alone. Aqua regia is a highly corrosive fuming liquid. It is one of the few reagents that is able to dissolve gold and platinum. Now let us see how metals react with the solutions of other metal salts. When we take iron and dip it into copper sulfate solution, and if we take copper metal and dip it in iron sulfate solution and leave it for 20 minutes, we can see the solution in which we kept copper, there was no reaction. Whereas when iron was dipped in copper sulfate solution, a noticeable reaction was observed as this. Reactive metals can displace less reactive metals from their compounds in solution or molten form. We have seen in the previous section that all metals are not equally reactive. We check the reactivity of various metals with oxygen, water and acids, but all metals do not react with these reagents. So, we were not able to put all the metal samples we had collected in decreasing order of their reactivity. Displacement reactions studied in chapter 1 give better evidence about the reactivity of metals. It is simple and easy. If metal A displaces metal B from its solution, it is more reactive than B. So the reactivity series is a list of metals arranged in the order of their decreasing activities. You have learnt in your previous class about the electronic configuration of the elements, and you've also learnt about their tendency to gain and lose electrons. So we therefore explain the reactivity of elements as a tendency to attain a completely filled valence shell. A sodium atom has one electron in its outermost shell. If it loses the electron from its M shell, then its L shell now becomes the outermost shell, and that has a stable octet. The nucleus of this atom still has 11 protons, but the number of electrons become 10, so there is a net positive charge giving us a sodium cation. On the other hand, chlorine has 7 electrons in its outermost shell, and it requires one more electron to complete its octet. If sodium and chlorine were to react, the electron lost by the sodium could be taken up by chlorine. After gaining an electron, the chlorine atom gets a unit negative charge because its nucleus has 17 protons and there are 18 electrons in its K, L and M shell. This gives us a chloride anion. So both these elements can have a give and take relation between them. Sodium and chloride ions, being oppositely charged, attract each other and are held by strong electrostatic forces of attraction to exist as sodium chloride. It should be noted that sodium chloride does not exist as molecules but aggregates of oppositely charged ions. Now let us talk about the properties of ion compounds. They have high melting and boiling points, indicating strong bond strength between ions with greater positive and negative charge. Most are crystalline solids at room temperature. Ions in a regular geometric pattern, that is, they exist in the crystal lattice. They are hard and brittle, and they conduct electricity when in molten state or dissolved in water. Thank you. This was all in this chapter. Have a nice day.